So firstly, yes, it was my introduction and it's been done for the day. And what are your, expectations about the course? And what are we gonna, that is knowledge transfer. So basically it's for Docker and Kubernetes. And, the contents, like what are the syllabus we gonna cover? And what are the contents or what would be the real-time scenario? Practical examples, including more concepts. So now let me go to what is Docker and Kubernetes. So for today, it will be first, what's Docker, what's Kubernetes. This is 2 minutes, please. It's not allowing me to jump in. I'm just opening a notepad. Give me 2 minutes. Yes, I'm back. Just let me know once my screen is visible. So is notepad visible?
Not visible.
Not yet.
Look, why this window is here?
We are looking at your browser.
So at least by now, this could
Yes.
the notepad. Okay. Yeah, and agenda the delay. So agenda was intro, introduction, that's been done. And the training knowledge. What are the contents we're gonna cover and the outcomes. Now, before diving into what's Docker and Kubernetes, I just wanted to give an intro about what's DevOps, because this Docker and Kubernetes, these two concepts are something that comes under DevOps. Usually, whenever we say what's DevOps, like how one will answer for the same. Like, collaboration between development and operations team. That's what the usual it is, correct? Yes, that's also a right answer. But apart from that, I can say DevOps. What is DevOps? It's collection of tools. What are the tools? Right now, I was saying about Docker and Kubernetes, but under DevOps, what are the other tools would be? Like Git, GitHub, Git Actions. Earlier, it was Bitbucket, and for scripting, for configurations, we'll be using Ansible. So for Git, where we'll use for to maintain the versioning control system. So for versioning control, and Ansible for configuration, which is a scripting as well. Next is something Docker, Kubernetes. Before this, we do have something called Terraform, Git, Maven, Jenkins, and many more tools. Okay. So DevOps, it's not something that's been limited to 7 to 10 or 15 tools. It's all about, we do have a number of tools, but every day, what, in day-to-day activities, and it's a project perspective. So depending upon the project, one will be using the tools. That's why we said DevOps means obviously it's a collaboration between development operations team. But I can say, and the one more answer be something we can define in such a way that it's a collection of tools. So what are these that will be useful for the same? So when I say versioning control, it's something like where we upload our code and collaborate with other colleagues or team as well. Just an intro. And what is this map? It's for building the project, and it's Java based, used for Java based ones. Building projects and Java based. What is this? Jenkins. And this is a configuration tool. Automation, for automation purpose. This Terraform, infrastructure as a code. Infrastructure as a code. And then we come here, Docker and Kubernetes. So this Docker is for containerization. Containerization. Kubernetes, it's for orchestration. So now I just give you a intro about DevOps and what the tools, have a number of tools apart from these, like for monitoring and logging, we'll be using Prometheus and Grafana and so many more. But as now, it is Docker and Kubernetes, we deep dive into the concepts. Firstly, let me say what's Docker. As I have said, containerization. Why do we need, and what is the difference between on-prem and virtualization and containerization? I can say basically in virtualization, what will happen? We'll be having something called 1 minute. So where in on-prem, basically how would that be in an on-prem where we'll be having a complete server. So 1 minute. So where we'll have on-prem server, and within that we'll be having a number of systems being connected over there. So it's like individual systems for each users being assigned. So that is solely dedicated for those individual users. Wherein if a user is using that system, or if it has been allocated for a particular task or something, which cannot be occupied by other person. So that is how it will be. But whereas in order to overcome from that means for example, where if you need to stop the process right now, and we need to just uninstall Windows Server, which is already been using, and we need to install Linux or Ubuntu. In that case, we have to reinstall and configure completely. That is what is on-prem or a main. What about, and in order to overcome from that, there is a concept of containerization. Then it comes with virtualization. What is this virtualization will do? Basically, there will be a server, and in that server, there will be upon that particular hardware, there will be an operating system. That is a guest operating system, wherein if at all if you need Windows, then one can go ahead and launch. And wherein to go for virtualization, we have a number of tools like VMware Workstation, Player, or I can say Oracle Virtual Box, wherein we'll download ISO images from the Google with respect to OS or SUSE or any RHEL based versions. So we'll be downloading and we'll be loading, and which takes almost, I can say it takes more than 2 hours in order to like apply all the configurations completely. So virtualization, what is the use and drawback? So for virtualization, we had overcome the drawback of on-prem, wherein if we need to configure completely, like in order to reinstall or something, we have to just erase the complete data and we have to reinstall. But when the concept of virtualization has come, it's totally like based on the original RAM or storage, whatever been assigned. So from that, these virtual machines will be getting when we assign 4 GB, a particular Linux machine should take only 4 GB of RAM and some 20 GB of storage. Then we can assign. So it will be taking from the it will be allocated as per the requirement. If you are done with that work, and if you just wanna stop using the Linux, then we can just terminate. So that shared resource or CPU or memory, whatever, it will be used by other resources. Like when we launch one more VM with respect to Windows, so it will be useful. But what is a drawback here? Again, in the virtualization, if at all, if we need to, like at a time, we can just run only one particular, like launch 3 virtual machines, and in that we can have virtual guest operating system being installed. But it is not that it is so dynamic. What if we need to run 2 to 3 virtual machines at the same time with independent? So that was one of the drawback. And then the concept of containerization has come. Containerization, wherein what we'll be doing here in the containerization is it's a lightweight and it's an alternative for a virtualization, as I have told. What will it happen in this containerization? It will totally will have all the dependencies, applications, and the dependencies being packed together. So no need to just like have independent different where it will be stored in a different location or something. In this containerization, if you just want to use Linux, you can just download like as for a Linux image, so we'll getting that, so you can run. And at a time, if I need to run in one in one scenario I have to run Linux, and in another scenario I have to run Windows, then it is possible that it will be isolated from each other, that it's totally an independent process. And for containerization, the best example will be Docker. And hence we are into the Docker and Kubernetes. And why do we need this Kubernetes then? What is this orchestration? See, when I say containerization, it's all about we are creating. In Docker, we will be creating single or standalone, which is something a standalone container. But in Kubernetes, it's nothing but orchestration, multiple containers. So there multiple containers can be, just it is totally for managing. In Kubernetes, we do have some concepts like pods or something wherein we'll assign a label and priority for that. So which will run accordingly. So we'll go to that orchestration later. Let me just complete the Docker. What do we say when I say isolated from each other? See, right now in this Chrome, I have online notepad been open, and meanwhile I can just open one more tab. But what does it mean? Okay, right now here I'm using for notepad, and in another window I can have like Gmail or any other like Google Docs being viewed. So both are isolated from each other, correct? It means it is not visible, or the actions, it's not totally merged, which is independent from each other. So that's the advantage here. And I can say it's a stateless. What do you mean by stateless and stateful? Stateless and stateful. Stateless, I can say, which is not a persistent. Which is not persistent. It means we'll create a container, we'll use it, and when we don't require anymore, we'll be deleting it. So the next time when you just log in, you'll not be able to view that. And what is stateful? It is something that is persistent. Usually when we go to ATM or somewhere, when we draw money, whenever we withdraw cash from the bank or ATM, it will all be logged in our passbook details, right? So wherein previous histories will also be recorded. Stateless means I can give a best example of weather condition. Okay, right now I can just go to Google and say, hey, current weather. And tomorrow I'll just go to the same like weather.com and I'll be checking the like what is the weather now. Would that be same? No, it's totally a new session, which means it is not persistent across. Stateful means it is persistent. And I can say Docker, it's a stateless, which is not persistent. And in order to make that persistent, we do have multiple concepts, wherein for that concept we do in order to make that persistent, we do have a concept called Docker volume. Docker volume. That is something in order to for persistent storage. For persistent storage. When I say Docker, like containerization or repository, and when I say Linux image or something, definitely we have to have something. What are required in order to create a container? Okay, requirements to create a container would be, the first thing would be, like you have to know something like Docker repository, Docker hub, what is an image. So we do have Docker hub, wherein it will be having n number of images where we can use and we can download it, which will be shown on a day 3 during a demo, like how are we exactly downloading an image and how are we creating a container. So right now it's like Docker Hub will be having a number of images. We will be, naming it and downloading from the global repo. Global repo means from the Docker Hub, wherein even I can also use, and all over the globe, all the users can also be able to use. So when I say local repository, it is something which is dedicated only for my visibility. Okay. So from there, we'll be downloading images and we'll be doing it. And when I say Docker image, or if example, if I need a Linux image to be downloaded, then we do have some commands like Docker run. Then the image name something would be like Ubuntu. If I need to download, then Docker run -itd. We'll be knowing it in depth. Ubuntu and later, if at all, if not, then so that once we run this command, we'll be getting the image of Ubuntu, which is useful. It just take only fraction of, I can say it takes only fraction of seconds or minutes. In a complete operating system is ready for us to use. That is the containerization concept. Compared to virtualization or on-prem, this is being widely used. Now, like for example, I can say what a Docker containers, it's done. Containers is done. How it's generated, we'll be running or executing the commands called like Docker run. We'll be instructing, so we'll be getting the commands. And next would be something wherein using this we'll be writing our own image. Like we'll be extracting and how it has to be done, and we'll be pushing it to Docker repo so that it will be widely available, globally useful. Okay, and that is also one of the concepts where we'll be writing it down. And networking will be covering the concept of Docker networking, which will be having bridge, overlay, and other kind of networks. And also Docker compose, which will run, like 2 to 3 tasks at a time. It's something called, be using a YAML file, that is .yaml, the extension will. So we'll be writing the script and we'll be executing the same. Why Kubernetes? Or is this something that don't we have any other orchestration tool? So in order to go to Docker, we do have a orchestration called Docker Swarm, which is useful for orchestration, that is to manage. And using this, it's also it makes use of high availability. That means even if one container will be failed or one pod gets failed, one can just make like have a backup or a recovery, which will be working. And what are the cloud, or is it something that is only Docker Swarm and Kubernetes and not others? Yes, we do have other orchestration tools which will be cloud managed ones. In AWS, we'll like Amazon Web Services, EKS, that is Elastic Kubernetes Service. And in Google, in GCP also we do have. So because when we say cloud-based, it's almost like Amazon. And Azure also we do have AKS, that is Azure Kubernetes Service. So these are something which will be provided by our cloud providers, the services. So now it's been into this Docker. Now let's dive into Kubernetes. What are the syllabus we do have, or what are the concepts we're gonna cover? Here we'll be using kubeadm. The terminology might be new, but we'll be knowing it. So we'll be using kubeadm and KOP, that is Kubernetes operations, in order to like have our one-to-one hands-on session during our classes. We do have another tool called Minikube, but we are not using it because it's something like a bit advanced level. So we'll be going on with this Kubedium. So orchestration, and I do like something called pods or something, and it acts like, like instructing, hey, you run this container, or you perform this task. So we do have some like workload components like pods. I'll just explain what I mean the terminologies of that. Replica set, in order to maintain high availability, we'll be replicating it. And deployment, what does it mean? Stateful set, as I have told you, in order to make the like a data persistent, what are we gonna do? And daemon set, and next some services of Kubernetes. For Kubernetes, we do, I mean, there is a terminology that is KTS. And what is the cluster IP, node port, load balancer. Why do we need this? I'll just explain after all this. Headless service, ingress, props, sidecar containers, and advanced scheduling, like prioritizing it. Also something that is RBAC, that is role-based access control. If I need to limit the usage, how will we be doing it? That is why RBAC. Storage, Kubernetes, how storage would be. And host volumes, EFS, that is elastic file system, which is kind of like shared volume. And health charts. In Kubernetes, when we say there's something that's been widely used, that is Helm charts. And also ELK stack and Istio service mesh. Okay, these are the concepts that's gonna be covered in Kubernetes. And when it's to Docker, you have concepts like what are containers, how do you execute it, and how do you make it permanent, or what if I just run this, we'll be getting it, but what if we just need to have our own image being uploaded in Docker so that it will be widely used or accessed everywhere. And how we'll be writing a script when we say .yaml, how would that be executed? And also we do have other concepts with respect to like port mapping. For example, internally we'll be having 80, or we'll give some number in order to access externally. For example, right now you think this is a screen wherein if I just get out of this online notepad, that's something isolated, right? This is limited only here. But if I need to add the same container, even from my base in, or even if I provide you the URL, you all have to access. So in that case, how will be mapping? That is something called port mapping. How do you externally, port, and how the mapping would be done? So these are something, the concepts with respect to Docker. And with Kubernetes, we'll be having this pods. I mean, these are some terminologies. Some might be hearing it for the first time, or some have already been into this, very well aware. But I'm just, giving an overview, because when we say it's 25 days, like with the course, or it's like something like Kickstart for the same. And it's and for the next 2, that is including today, it's a day of session, and for the next 2 days we'll be having, like, we'll explain in detail like what all in pod means what we'll be doing, how we'll be writing the script. We'll just give an overview, and on day 3 we'll just execute some sample codes to show how exactly it would be. So then we'll have some complete knowledge, because if I take only for today, then it will be something like everything will be up together. So that is the reason we have divided our session in 3 sets. So we'll be having even tomorrow and day after tomorrow as well. Okay. So whenever, let me come to this Kubernetes. So what is the pod means? It's just like a, there we call it as container. Here we call it as a pod. So we can have n number of pods. It's one or more containers. One can have one or more containers. And it's something, it's very, even Google definition would say it's the smallest unit, smallest individual unit, smallest individual unit. Smallest individual unit. And what is this replica set? As the name suggests, so that we'll be having replicated number of pods being running, so that if one pod, for example, we have run a container, there we say container here in a pod, so in pod will be running executing a container, and what if that fails, it got crashed or something. So that's the reason we'll be having this replica, so that it will make sure that 3 to 4 set of same pods are being executing. Okay, that's come to replica set. And what is this deployment? This is something. 1 minute. It's a stateless application. It will be managing the stateless applications. So even here also we do have YAML script, wherein we'll give the name as pod. When I give the name as pod, and when we write a code, the pod will be created. And when we say replica set, the terminology itself is a replica set, so that it will create, and we have to provide number of replicas. For example, 3 replicas or 4. So that will be done. And here in the deployment, it makes sure that the specified number of replicas are running. So the main job of this deployment itself is making sure that if I 4 replica set, then this deployment will take okay 4 number of replicas are being executing. And what is state set? It is something, it makes sure that the data is persistent. And what is this daemon set? It makes sure that pod will run on cluster and all the nodes in a cluster. So in a cluster we'll be having a node. So in all the nodes, it makes sure that a pod is executing or pod is running. This is something with respect to workload components. And when we just come into the services, it is something, cluster IP. What would that be? Something services. As I have mentioned earlier, the port mapping in Docker, wherein we'll be executing internal port, and when I say external, even you all can access. Internal means it is dedicated only inside the Docker. So how would be making it? By a cluster IP. That is what. So we'll be exposing the service on a cluster IP, cluster internal IP, so that it can be accessed within the cluster as well. And what is this node port? It will be exposing a service. In a cluster, it will be executing a service on a particular static port, so that it can be accessed via node IP : node port. So we'll be knowing it in depth. Once we understand with Docker port mapping, it will be easier for us to understand what is this cluster IP or node port or something. So this is why Docker and Kubernetes are something. Without Docker, if you just go straightly to Kubernetes, it is something bit difficult, where the terminologies are something advanced or level. And when I say load balancer, we all aware of big billion days or something, wherein whenever there is offer or sale is going on, lakhs or crores together, the users will be accessing the same website or a same URL at the same time. So for every fraction of seconds, there will be 1,000 or lakhs together requests. So in order to do that, it is not something that the server should always be available. So what is this load balancer? It is something that it will be managing the load. So whenever there is something like 100 requests have crossed its limitations, then it will be, it will be the same load will be transferred to another node. That is something with load balancer. And we'll be having something called external name as well. That is with respect to DNS, domain name system. So how we'll be mapping it? That's also one of the concept included here. What is this headless service? It is something, it will be allowing us to directly communicate with the pods. So again, what is a pod? That means it's something will create a container. So inside the pod, a container will be running. So what is this headless service? This is something it won't be having, it's a service that will not be having any cluster IP and will be, it will allow us to direct communicate to pods without any IP. So that is something headless. Headless means it doesn't, it will not be having the tag kind of, that means IP. And next we come with ingress. That is something, it will allow in all the inbound connections, to reach the cluster services. The terminology like cluster service, these are all something, that can't be catched at first time if we are novice into this completely. But, we'll be knowing in depth along with the, scripting, along with code, like how do we create a particular service, how it is gonna reflect and how it is executing. And it is mainly used for HTTPS routing. Actually, this ingress. So how are we doing it? We will be knowing in depth. Next, coming to props or sidecar containers. So these props will make sure that, like health check. In AWS, we do have CloudWatch or any monitoring, logging or health check in order to check if the particular, pod is healthy and it is running and it is making sure that required memory and storage space are being provided and it is working totally fine. So this is something called as health check, to check the readiness, if it is ready or if it is running or something. So this props will, help us to determine the healthy condition of a pod, or to know if it is active, inactive, or it is the execution has been completed. Okay. And when I say sidecar, as it says, it's an additional functionality apart from the main container in a pod. It is something that will be useful, that will provide additional functionality for logging and monitoring. And we do have other concepts like advanced schedule. That means, what if I have 5 to 6 containers been executing, pods, so that I need to prioritize them. I need to make sure that only that particular pod in a node is executing particular task. So that is something we call it as advanced scheduling. How are we doing it? Like, for example, we'll get a real-time scenarios wherein please make sure that you are executing a pod in a particular node being described. In that cases, we need to schedule it. That means advanced scheduling. When we just run a container, it will be executing on a the node which is being available. But when it is advanced scheduling, we'll be having something called node selector or node affinity, toleration range, pod affinity, and pod anti-affinity as well. That means it's totally dependent on making sure that that particular node and that particular pod is executing a particular node well. So for that particular node, we'll be giving it a label, and we are making sure that pod is executing on that particular node. These are something, a bit advanced level of concept. So we're gonna cover all this, whatever have been listed, and some subcons as well. And coming to this RBAC, it's something role-based access control. For example, I'm an admin, and if there is one more, a normal or a guest user, then definitely not every user will be having a same privileges. Correct. So that this is something we are restricting access. So based on the roles, we'll be granting the access. For admin or root user, it is something the user will be having a complete authority or a complete access. When I say a guest user or just a normal user, then we'll be restricting the access. Like, okay, they might a particular user might not have a access or rights to delete a particular pod or node or something like that. Okay, so we'll be knowing that as well. And coming to storage, we'll be knowing about host volumes or persistent volumes. As I said here, under storage only it will come. How are we making it persistent across? How are we doing it? And how exactly a temporary storage volume created when a pod is assigned actually? And how it will be existing? Because when I say a container, definitely there should be a data which is in, right? So and next is it comes with EFS. As I already told, EFS means it's a shared volume wherein I'll be creating a mount point, or let me just frame it in a basic level, I'll be creating a folder so that I have to share it with another user or one of my colleagues. So what we will be doing is we'll be having this concept of EFS, that is Elastic File System. So I'll be sharing it so that even my colleague or another user will also be able to view the content, or if at all, if I have given the rights to edit or modify or delete, then definitely he'll also be having it. I can say it's like a server and a client level. For example, if I'm the owner or if I'm at the server kind of, wherein I'll be having all the authority. And for some clients, I have to grant permission just to view or just to modify. That is also be possible. So in EFS, this is something a shared volume. How will, and next comes with Helm. In Kubernetes, whenever we say or whenever we hear, and there is also one more terminology called Helm. It's a package manager for a Kubernetes. In Linux and all, when we say what is a package manager, something will be, or many of you might be aware. In Linux, we'll do sudo yum install. I can say it's HTTPD or sudo yum install nginx. For example, if any server needs to be installed. Yeah. So here in this Kubernetes, Helm is a package manager and it uses a chats to install, upgrade, or define the applications. It's like a pre-configured template. We'll also be executing it because Helm chart is something that's been required for this concept. That is also one of the thing. And next thing would be, what is this ELK stack? It is something for logging. It is used for logging. Mainly this ELK stack is used for logging. Definitely whenever we are doing or executing a task, we should be aware of, or we should be knowing what and all the condition is actually. So this ELK stack is also one of the concepts wherein I'll be using for a logging purpose. And next would be something Istio services. It is something, it provides advanced traffic management as well as security and for monitoring and for routing in Kubernetes cluster. Okay, so these are the concepts that we're gonna cover in our 25 days. Okay. Yeah, 25 days. And 3 days we'll be having a demo. 3 days will be our demo session. And today is the day one that we have done. And for next 2 days, the same thing will be, we'll be having in-depth or sub-concepts, what and all will come under exactly in Docker. And what is this cluster IP? A bit in-depth level. And on day 3, we'll be having some minimal, or I can say a practical hands-on. How exactly in this Docker, how we'll be executing or creating a container, we start or stop, how do we, or from where exactly the image would be available. So once we finish the Docker, then we'll start with Kubernetes. So it will be easier for us to know some terminologies in prior, as well as to know, because nowadays you all might have heard that, cloud is something that's taking a higher, and it's aiming and booming. And wherever you go, it's something that, Kubernetes is something there, like it's main, because we are, developing and the technology is way far, because during earlier days or earlier times, it was something only on-prem, wherein it used to have particular dedicated server rooms, maintaining for the same, and number of users who are managing would also be more. And there was like a dedicated task assigned to a dedicated team as well as a dedicated person. But now it is not like that. That we have understood by comparing it with on-prem and with this virtualization, then comes with containerization, then comes with orchestration. So this is something, like inline alignment is there. So in on-prem, only particular server, suppose think right now we all have a desktop with us, correct? Right now, even I'm only using Windows. What if I need to use Linux? What will I be doing? Do I need to completely format it, right? Reinstall the OS, correct? This is what we have to do. So in Windows, all my data will be, okay, I can take back. then it's like complete a new version of operating system. But so this is something like on-prem. What is the next level? That comes virtualization. Means use Hyper-V, or in Linux we do say KVM. So we do nowadays, I mean, recently we do have a built-in hypervisor in our laptops. So with using that, we can have dual OS. But we can't operate at a time, but it is something we can just switch in between, either that or this. So that comes under virtualization. So when we are just, having it virtually we are assigning it a memory. And when I don't need, when when I'm not required, I can just simply delete it or uninstall it. And next, the higher level concept will be something containerization. As I said, it just takes only a minute, less than a minute, in order to create a particular OS image. So where we'll be using an image. So in fraction of seconds, it will be created. Few of you might be aware of AWS as well. In AWS, we do have something called Elastic Compute Cloud, and we'll be, like executing it. Correct. So we'll be using that here. We'll be knowing the advantage and disadvantage as well, and how that's gonna be okay, containers would be used to create and maintain, create, that is get the image globe from internet or download from Docker Hub repository and an image. What is the use of this orchestration? We are making sure that it is it's completely a managing orchestration. It will take care where it has to run or what are the support we have to provide. So that is something that comes for Kubernetes. So for today, I'm done with the session. And we'll be having day 2 for tomorrow at the same time. And on day 3, that is on Friday at the same time, that's 7 to 8 p.m. And for more info, the details have been provided in the chat. So once, okay, I have some chat. Let me just go through quickly. Sampath Kumar, unable to hear. Okay. That even pursue a Docker should also understand. See, that's what I have told. I guess now you all might be like, knowing what is this Docker, as I have given comparison. No, we are not going to use for this. Will be using Amazon EC2 instances, and where from there we'll be launching or going on with the installation of Docker and Kubernetes, and we'll be experimenting it. What are the prerequisites? There is no prerequisite, but it is good if you have a knowledge of cloud, basics cloud concept. Let me just go from one by one. I guess I have explained this Docker. Yes. And here is the detail that if you have, since you can reach out to so and so contact and name. And if at all one have registered, I mean, once you register, we will be having our real-time classes starting from Monday. That is the coming Monday, 14th. You can save the info. Okay.
Hello.
So we do have, apart from here. Sorry, yes.
Yeah, Fawaz here. I have a class going to start at 8 o'clock. So I just have one
Yes,
question.
yes.
I have
Okay.
one. Yeah, so I am basically studying AA and AML. So I just want to know how
Okay.
Docker will help me here. Is it only for the DevOps technology? It will be helpful for me also.
Yeah, you can just use it as per your project requirement. That is the reason we are not limiting our syllabus or content like, okay, it has to be useful only for cloud. No, it is not like that. We'll be explaining so that even a novice could understand it. So you can apply based on the project. In A&ML, it is not much involved, but it is completely dependent.
Okay. Okay, so it is project dependent.
Yes.
Okay. Okay.
For example, if you need to just bind all the applications dependencies at a one go, then obviously this Docker would help, right?
Yeah.
And also you will be using some libraries like PyTorch or scikit-learn,
Yes.
TensorFlow. So even this will also allow us. I mean, this Docker will also allow you for like training or testing or deploying the models. It is something it's very quick and you can make utilization of it. And also isolation, as I have told you, it's something that in like completely isolated, and you can expand as well.
Okay. Okay.
And when we, so this is not something that's limited to cloud. You can
Okay.
just apply as your project needs.
Okay. Okay. Thanks, Lord.
Yeah, sure.
Yeah.
Is it mandatory to know AWS and cloud before this course? It's not, I mean, literally mandatory, but it is good if you are aware. Otherwise, yes, there is a separate, class for the same for AWS. Are we going to? Yes, I have answered this. It's killer coda. We'll be using AWS instances and prerequisites. It's okay if you know, if you're aware of cloud concepts and AWS. The Prometheus concept. It's for logging point. No, this is something. Ansible is not something covered here. I was just giving an intro that in DevOps tools, the most useful tools, what and all will be. I was just writing it. If at all, if you take all this, then it comes under a complete DevOps class, and it's not gonna take 25 years, almost 2.5 months in order to cover concepts one by one. And in Ansible, obviously, we'll be using our YAML script. I guess yes, we are done the demo state. Many of you might should join. Kindly let me know how it is useful to experienced Java developers, Spring Boot, microservices. See, Docker and Kubernetes is actually completely a process based one. So I'll be letting you know how will it be useful in tomorrow class. Will be fine because it's almost 8 and many of you would be having other session. Yes, we are done for the day. We'll just keep okay. What is the total number of days for this course? Also, we get lab. You lab sessions and also materials. It's 25 days. I have many here. Okay. I have no knowledge about cloud. Is it possible to continue? Yeah, we'll give the intro. If you are not aware, then I'll just give a basic intro of cloud. Will there be notes? Yes, we'll be having shared notes, video as well, every day. Okay. And also the materials. If you have any doubts, you can reach me as well with respect to notes or something. So we'll be having recording as well as we'll be uploading every day. Yes, so we'll catch up on the same time tomorrow. So thanks for joining everybody over here. We'll continue tomorrow as well. Have a great day. Thank you so much, all of you. Have a great day. Thank you. Bye. We'll catch up tomorrow.